So, good day, everyone, and a very warm welcome to NDT Talks. We are glad to have you join us for the session 2 of our February series on a topic extremely relevant to today's industrial and infrastructure landscape. What role does NDT play in predictive maintenance for critical infrastructure? Across sectors like oil and gas, energy, ports, transportation, and heavy industry, infrastructure assets are aging, while operating conditions are becoming more demanding. Downtime is costly, failures are unexpected, and safety is non negotiable. Predictive maintenance has emerged as a key strategy, and at the heart of it lies non destructive testing, enabling condition based decisions rather than reactive actions. Today's sessions brings together leaders and practitioners who work closely with asset integrity, reliability, corrosion, and maintenance optimization in real world. We are privileged to have a highly experienced panel. Joining us today are Mr. Tawfiq Mohammed, Chief Operating Officer at Arise Global, with extensive experience in operations, asset reliability, and industrial services across regions. Mr. Dheeraj, Asset Integrity Leader, Principal Engineer from Oceaneering, representing advanced inspection and integrity solutions applied to complex offshore and industrial assets. Moderating today's discussion is Mr. Vineet Yadav, Quality, Project and NDT Manager, ASNT Level 3, with deep expertise in NDT, cost optimization, continuous improvement, and project execution. So with that, I'd hand over it to Mr. Vinny to take this discussion forward.
Hey, thank you for the introduction and warm welcome to everybody joining us today. So, predictive maintenance has become a strategic priority for organization managing critical infrastructure these days, but it only works when decisions are backed by reliable data and engineering judgment. So, today's discussion is about understanding where NDT truly fits in predictive maintenance beyond buzzwords and how it helps asset owners move from time based to condition based maintenance. So let's begin by setting the foundation. So I would like to like ask about the setting the context actually here. From your experience, how do you define predictive maintenance in the context of critical infrastructure, and where does NDT play its most important role today? So, Mr. Dheeraj,
Yeah, sure. Thank you,
I mean,
Vineet.
if anybody wants to jump on and like give their thoughts and share some information.
Yeah, I'll go ahead. Thanks, Vineet, for setting the tone.
Very warm welcome, everyone. So I think in my view, predictive maintenance has been very important, vital. Like for example, in my experience working as an RBI engineer back in ExxonMobil, for petrochemical plants, predictive maintenance has been the key life, because it gives happy sleep, safe sleep to the management in knowing that the plant is reliable, predictable outcomes from the plants. Even for upstream sectors, right? So I've seen cases where, especially like advanced ultrasonics, TFM FMC has given early case detection of HDHA and other important defect mechanisms, where without predictive maintenance, you're going to be like counting on the days, or you're like just going to be blind on not knowing when your unplanned shutdown is going to come up, right? So I think predictive maintenance has been really the key in enabling the reliability of the plants, ensuring that you don't have unplanned shutdowns, and ensuring that the financial stability of the operations of the plant is kind of stable, right? So just in a nutshell, yeah, that's the importance of predictive maintenance to me. Probably I'll open the platform to the other panels.
Yeah, very nice. Anybody has anything like want to jump on and add their views on thoughts?
Yep. I think I can add something here. Hello, everyone. This is Tawfiq, and it's a pleasure to be with you today. I mean, from my experience, when we speak about the predictive maintenance, especially when it comes to the critical infrastructure, I mean, the meaning for me, it has been always that it is the shifting that happens between from the state that we used to do the action after the failure into the state that we predict the failure before it happens. So This is the main value we are looking for from the predictive maintenance rather than waiting to operate to fail. No, we do our own groundworks using the NDT and inspection method available now in the market, so we can expect the failure before it happens. And definitely that cannot happen without having the NDT. And I would even like especially speak about advanced NDT comparing to the traditional NDT methods, considering the coverage we can get from the advanced NDT versus to traditional methods, the speed of the inspections, the accuracy, reliability, all those kind of things. So NDT has been an added value that really helped a lot to bring predictive maintenance into the picture. And I would say that NDT is indeed the backbone of predictive maintenance. That without it, you cannot really stand and have a case, or else the other way, it would be just like a guesswork rather than reliable predictive maintenance procedure. Yeah.
Yeah, like you said, from preventive to predictive. Like even Dheeraj pointed out, like so many organizations are transitioning from preventive to predictive maintenance models these days. So what do you guys think? What role has NDT played in enabling this shift, and where do you see organizations struggling the most? Anybody want to share like what you might be experiencing in your current organization or company?
Okay. Can I may continue?
Yeah,
Right.
yeah, feel free to do that, Tawfiq. Thank you.
So, yeah. Well, to shift from preventive maintenance into predictive maintenance is really change the concept of the time-based inspection into condition-based inspection. You know that we have been following the time-based inspection all the way, long time back. You know, we have to do the internal inspection every 5 years or 10 years, external inspection every this number of years. Okay. Which is not actually accurate enough to build a reliable maintenance plan. So the right thing is to be a condition-based like tool rather than a time-based tool. And here where NDT actually has helped a lot in this transition, because using NDT you can get measurable data that you can use for whatever assessment you want, like to estimate corrosion rate, for example, to estimate the crack growth, to know what is exactly the rate this equipment or this asset is degrading, so you can plan better for your maintenance and so on. Yeah, so my statement would be to change from schedule-based NDT or inspections into condition-based inspection, and this should be according to the risk and consequence of failure for each equipment. So I would not do this kind of inspection blindly. No, I have to do the study. I have to know exactly what risk categories I'm having within the plant, and according to that, I start deploying NDT. So I can reach to the condition based on what I can decide what action next to do to ensure the safety of the asset that I'm running. Okay, so in short, I would say that to enable the predictive maintenance, we would really need to change from time-based into condition-based, considering the risk factor of this specific asset. Yeah, so this is what I can say in this part.
Thank you, Tawfiq. Yeah, I agree on that. So Anybody else want to share something from their experience based on their industries or like company?
Yeah, I mean, probably I'll go ahead. So
Thank
I
you.
second Tafik on that. So, like based on my personal experience as well in working on a lot of risk-based inspection projects and oceaneering. So the main concern is like time-based or schedule-based is kind of very simple in terms of planning. But when you want to transit from kind of a preventive or time-based to a predictive, which is RBI risk-based, right? You need a lot of inputs from the mechanical corrosion aspects or the operational and the process aspects as well. You will need to know the operating parameters, whether they are within the operating limits in terms of a corrosion perspective or a cracking mechanism in terms of temperatures, brittle fracture and all. So it takes a lot of efforts and joint hand from probably inspection, materials, mechanical and chemical engineers. But I've seen it firsthand myself, right? Executing RBAs, creating RBA. But once you do it, you see the effect in the long term. Because if you see time-based or more like uh, just like run to failure kind of approaches, you really are just kind of doing a guesswork or just kind of gambling on it. But when you start doing risk-based or predictive maintenance, you really know what is the consequence of failure, which is the important asset you want to look at first, and what is the probability of failures. And you do a kind of pre-plan inspections to drop the probability. And the value probably comes in long term, right? And in fact, most of the times the scope of inspection really drops and you really go and nail down on the critical aspects of the inspection with the advanced NDTs instead of just doing kind of eyewash NDTs just to cover the time-based inspections. So yeah, it really takes a lot of efforts, I think, as Tafik mentioned, but once you have the collaborative efforts to bring the RBI factor inside, really the predictive maintenance has a huge advantage. That's my view.
Yes, sir, I agree. Do you think like you mentioned about the correlation and like data and engineering? So you do think like data plays also an important role, like in terms of like predicting like what, how, and you based on your data research, you can implement those things.
Yeah, I mean, I would say data is everything, but but what is important more than the data is the data consistency and the reliability of
Exactly.
accurate.
That's what I was to tell you. Like, what about the data accuracy? What if that we have data, but we don't know the like the accuracy of it and consistency? Then, which again, I think, according to Dheeraj's points, like engineering also plays a role. Like skill, you have to have a skill, like to in order to achieve that data, or to run that predictive test. And
Yeah,
and what do you guys think like about the what NDT technique plays the matter most for like in terms of like from like we have several NDT techniques these days. So which one do you think is the best to like what NDT approach provides and most valuable for predictive maintenance, and why?
well, this question actually is a good question, but I mean, there is no one answer to this question.
We
You
have
know,
enough time, so we can go with all the answers you got.
uh, I agree. I mean, there are a lot of advancements happening in the NDT. You have a lot of
Yes.
advanced NDT techniques at the moment.
Yeah.
Uh, but to say that which advanced NDT is better or which one matters the most, or what, it really depends on the case.
Hmm.
Like what is the damage mechanism in this? If you are looking for pitting, it wouldn't be smart enough to, for example, say that I'm going to use long range AT, for example. If you are looking for like a specific collision under insulation, doesn't mean that you cannot use ultrasonics directly without removing the insulation. So you have first to get the case, and based on the damage mechanism in this specific case, what material, what is accessibility, operation condition,
Yeah.
temperature, all these conditions together help you to find the right technique. However, from predictive maintenance perspective, you don't, I mean, you have to get a reliable quantitative data. So, or else your plan or your predictive maintenance plan won't be accurate enough to be implemented. Okay. So if you want to single out one NDT technique, I would say that ultrasonics in general or advanced ultrasonic are playing like the most important role generally in NDT sector. Mostly the data we use for assessment, either we use the corrosion data or we use the crack kind of gross information, and these kind of damage mechanism or defects actually most probably we can detect using ultrasonics. However, if you ask me about my personal opinion about this specific topic, I always prefer combination of more than one method rather than using one method. I always intend to recommend that we use the method that sometimes we call it screening, that can have larger coverage, volumetric kind of inspection, so I can get an idea about the entire structure initially, an idea, not necessarily very detailed information with very quantitative data, but I at least I get an idea about the entire structure rather than getting information about small spots here and there using UT thickness gauging or whatever. I prefer, for example, to use long range UT, to use acoustic emission, these kind of technique that can inspect big or large area, large structure, and pinpoint where exactly is the area of concern. And I go to this location where it was highlighted by the other techniques and do more quantitative kind of methods. For me, this is the most effective approach rather than doing quantitative technique, but at very small, limited areas that might not necessarily represent the entire structure I'm inspecting. So the short answer is that I would rather select a combination of techniques rather than going for a single technique. And of course, the main driving item will be the damage mechanisms that I may have within the as I'm inspecting.
Yeah.
Okay, so yeah, go ahead.
Just to add my perspective in a nutshell, I think Shafiq mentioned it in detail. I think there's no one best technique for everything. Myself, I started off very strongly in ultrasonics, but after having a real operator experience in the field, looking at a kind of a fixed chemical engineer within a petrochemical plant, I realized that each technique has its own advantage. Let it be like PT or NT, right? It has its own advantage in very specific cases. Like, let's example, if you're looking at a stainless steel cracking, chloride stress corrosion cracking or something, right? Sometimes it may be easier to just go and do a quick PT there rather than trying to get a complicated ultrasonics, right? So that really gave me the perspective with years, right? Every technique has its own advantages and for sure limitations as well. So my approach is more like screening, kind of a qualitative approach for understanding the whole perspective, and then going and nailing down on more quantitative technology to get more data for statistical analysis. Like, for example, if you would like to do a tube inspection, right? Doing iris may give you very kind of minute details of data, right? But it takes time, the efforts, and everything. So probably you'd like to go for RFET first to kind of screen, and then nail down on a couple of tubes and get more detailed quantitative data on those particular locations, just for an example, right? So yeah, I think no technique is the master of everything, but I think everything has its own advantages and limitations.
Yeah. I mean, I completely agree with you on that, Dheeraj and Tawfiq. And thank you so much for your thoughts on this one. But like you mentioned, Dheeraj, about data, and we did talk about interpretation and data, like how accurate are those data are. So my question is to you guys, like, it's kind of like data interpretation and decision making. So how predictive maintenance depends, like we all know, it not just depends on the inspection, but on interpretation of the data and action. How can any company, industry, organizations ensure that NDT data is effectively converted into actionable maintenance decisions.
Right.
Yeah.
I think that's. Shall I go ahead, Vinny? Yeah.
Yeah, please go.
Oh yeah, go ahead.
Yeah, thank you. Okay. So I think that's a great question. Because like as we spoke about the importance of NDT, different techniques and all, as we get more advanced and advanced, like probably in the last decade or so, we are getting with advanced phased array, like TFM, FMC, acoustic-based techniques, right? We're going subsea, even with my experience in oceaneering, we are doing ultrasonics at about like 3,000 meters below the sea level, right? Where we get a lot of noisy data, electrical disturbances, subsea disturbances, and so on, right? So interpretation becomes a critical factor, and it gets harder and harder, in my perspective, with the advancement of technology, because the skill set of the technicians or the person who is trying to analyze the advanced NDT or the complicated geometries or the scenario need to be kind of top notch. Someone who understands the nature of the object or the job, whichever we are inspecting, as well as the technology which we are using and combining it to make a decision for the operator is very important, because it's very easy to make some false calls and call something which is acceptable as a rejectable defect, or miss something which is wrong. Like in our cases, we are trying to see if the rises are flooded, right? 3 kilometers below the sea level. So in those cases, even minute indications are very critical. So one of the factors which we do, as it gets more difficult for human eyes for interpretation, we started using AI, right? So I will not fully depend on it yet. In fact, for our own use cases, we have been developing AI models to aid the human interpreters, to kind of ease the initial screening and so on, and to ensure that they get a second eye, cold eye review kind of a factor. But I think it will take some time to get maturity on the AI models and so on. So I think you rightly pointed out it's vital and more important on the interpretation, right? And it gets difficult as we just spoke about with the advancement of the technologies. So it gets tough, but I think with technology we'll get better, especially with the machine learning and AI models.
Thank you, Dheeraj. I think Tawfiq wants to share
Yeah,
something.
right.
Go ahead, Tawfiq, please.
Yeah. I agree with Red again about the quality of the data and the challenge you are having with the data, and maybe the possible utilization of the AI in the future, at least to like pinpoint
Yeah.
again where exactly we need to
I
focus
wanted to
rather
bring AI,
than
but Tawfiq, you did. That's great. I was like, we
he
haven't talked
already
about AI.
he has already mentioned he already mentioned before
Yeah,
me.
yeah, yeah.
Yeah. So I think I mean it's a trend nowadays is to mention about AI and how how companies are utilizing the AI in order to provide more reliable results. And I mean there are already a few companies in the market now that are offering solutions for AI for NDT. But in terms of how to do like or effectively use the data that we have from NDT and convert that into actionable maintenance decision as we have asked. I would split this into three parts. The main part is the data quality and consistency of the data, which really depends on several factors. The most important factor is the human being, the person who's actually getting this data and making the setup, doing the analysis, and so on. And of course, supported with qualified procedures, calibrated equipment, and so on. This all together helps to get accurate and consistent data. Okay, but this data alone is not enough because we need to use that to make like predictive maintenance plan. So this data must be integrated into a system that can convert this data into like assessments and information that can be used for a predictive maintenance procedures and plan. And I understand many companies in the market are doing that already. They do the NDT and they have the systems that can be used to integrate the NDT data. The third point, which for me is very important, is the ownership someone must believe in this data and the outputs and take action. Okay, because in many cases we know that we do NDT, we have reports, okay, but the plant operation condition does not allow that we do anything now. We cannot do that now. So you have to
Yeah.
convert these results and reliable results and that was processed into the system and came up with certain findings. You have to action that. If you don't
Yeah.
action
So,
that, so
so
there
I'm
is
going to
no
interrupt
point.
it here. So, who do you think should be responsible for the decision making?
Normally,
Like,
I mean, look, normally if there is an action that would affect the plant operation, of course, asset owner would be the person who is
you think asset
required.
owner should be from NDT side, like,
No, no.
or
NDT,
someone
my
from.
NDT role is limited
Hmm.
at the time that I deliver the data, okay,
Okay.
which should be processed by the integrity department later on into their
Uh-huh.
like
So you're
fitness for
saying,
service and
like, for example, some NDT person gave the data, so they shouldn't be involved in that interpretation, or no?
of course they must be
Okay.
interpreted
Yeah.
in their limits.
Yes.
Okay, and their limits means that they will do the interpretation, they will
Hmm.
give the findings, okay, and they will
Yeah.
say according to their standards, or not to the international standard, this is
Uh-huh.
acceptable or not acceptable. Okay, after
Yes.
that, I mean, of course, there is asset integrity department who will run that through. He can decide, okay, yeah,
Hmm.
we can live
Yeah.
with that. Maybe we can do some. We do re-rating to the equipment. We do certain things, so we can run under these conditions. Okay, or they may come up and say, no, this must require a repair. This must require, for example, a shutdown and so on. So there will be a severe action in this case. In such level, of course, asset owner must be involved, or the person who is like authorized to take such decision. So my point is that what I want to say is that NDT uh, or the data becomes value when it change or it provide a decision or it change a situation. Okay, but if we just do NDT or have the data to keep it in the files, it does not mean that we use that effectively for a predictive maintenance kind of plan. We just have documentation, not plans.
Yeah, what I feel like sometimes, based on my personal experience, if things are going on, people don't really care about the predictive maintenance because they want to keep running their business and they don't want to lose money. Especially it happens in operation
Exactly.
and head to head, like quality. Sometimes NDT comes under, most of the time, I think NDT comes under quality, and quality operation don't get along very well, I think. So
Yeah,
nobody wants to compromise. Oh, why are you really? Do you really think there are like something about to come up? Like we are talking about predictive maintenance.
yeah,
So yeah, so that's what kind of one thing.
yeah.
Like
And this is exactly the issue. Like that this predictive maintenance
yeah.
fails always at this point of handover between inspection and action. Okay.
Hmm.
Yeah, you did the inspection. Your role is over. Okay,
Yeah,
it's fine.
I agree
Okay.
100%.
Yeah.
I think
So the point that you have
yeah,
to action this so
yeah.
to get more reliable predictive maintenance plan.
Hmm. Does anybody else want to jump in and share their views, like Suresh, Gaurav, Kaushik? Uh, I mean, feel free to jump in. You can feel free to interrupt us. We would love to hear from any one of you, like if you want to share something. Okay, I feel like nobody wants to talk anything. I think Dheeraj wants to go ahead. Tawfiq, if I interrupted you, I think you were want to share talking about something else.
Oh, no, I'm good, Puneet. So I think,
Okay.
yeah, so traffic
So I mean,
summed it up pretty well. Yeah.
yeah. So what do you guys think about like cost? Like because of course, like I was kind of trying to get to that point, like cost. People don't want to interrupt anything. They want to keep running their operation. So because it comes at the end, everybody wants to make profit, which is like cost. So cost, risk, and asset life extension. So my next category I want to run into, and I want to hear what you guys think. like one of our promise of predictive maintenance is like cost optimization without compromising safety, of course, safety and quality. That's why we want to keep doing this. So how does NDT help balancing cost and asset life extension in like critical infrastructure?
Uh, I think I can give some examples.
Sure, we'd love to hear that.
Yeah. So as I mentioned, especially for like turnarounds and big shutdowns and stuff, right? Like especially before that, as well as during them, during the shutdowns. So we tend to go with a lot of predictive kind of NDT techniques to see if we really need to change something. Like for example, one of the critical factors, which was a big nightmare, was a high temperature hydrogen attack for some of the low alloy materials, which and especially because this HDHA was not something which was predicted when the materials were designed, right? But somehow in 2010s and something, it started coming up for the the equipments which were established in 1970s and 80s. So it was kind of a haphazard, and there were a lot of technologies coming up. Lavender was building up some specimens in the UK, right? So my own experience when I was working on such cases was we really had to do some critical NDT techniques. And in fact, we had to go through critical qualifications to see which technique is appropriate for such damage mechanisms. And then after you have a critical qualification on the technologies, then we had to apply it. And in fact, like after the application, we were able to push the replacement of the equipments or critical equipments. I'm talking about reactors and pressure vessels. Almost 70% of the replacements we were able to push it for about like 10 to 20 years, right? I'm just giving some numbers to kind of show you the scale. Let's say if we are not interested in doing the critical equipment predictive maintenance using NDTs, what is going to happen is either we are going to run to a bad situation with fire or failure, or we will be kind of going with replacing some things which are not in the dire need now and wasting money, right? So that comes to the cost factor, right? Whether you run to a failure, which is something not predicted, you end up paying more because you are in unplanned shutdown, right? Then you go into a premium kind of a replacement schedule to get all your plant up and running. Or let's say if you are not ready to do kind of a planned and predictive NDT to assess your risk and the probabilities, then in that case, you will need to go conservative and upgrade your metallurgy and change equipment, right? So in either case, whether you want to run to failure and take the risk, the cost is eventually going to bump up on you one day. Or in case if we want to kind of not apply this predictive maintenance and just go in for a replacement strategy, it's going to cost a bomb, right? And most of the times as engineers, inspection folks, or quality department, as you mentioned, right, it's a very tough decision to go and justify the inspection to the management team, operational team, and explaining them that if you spend, let's say some X amount on this, it's not, I don't think it as a cost, but it's actually a savings which is going to come 10 to 15 times or maybe even 50 times higher in a shorter 3 to 5 years kind of time frame. So I think the person whoever is doing that justification has a big burden on the shoulders, because that person has to bring in the inspection perspective from cost advantages as well as the savings perspective in terms of the long-term operational running, right? So not many people understand that it's always a tug war operation trying to push and reduce the inspection budget, and inspection people trying to expand the inspection budget, but it's a balance, right? So I think that's a critical part in optimizing the cost of inspection, at the same time justifying it for the right balance between operational maintenance as well as predictive maintenance. Yeah. That's my perspective.
Yeah, I love that. So, yeah. But like you said, it could be like for the cost optimization. And I would say even if you're keep doing the same, like continue doing your production and you finished your product, for example, maybe pipe industries, and those pipes, whatever you are manufacturing, it's going to end up with a boiler or something. It may end up like really big issue, like safety issue. And of course, like you may end up like different things like you just name it. Yeah, yeah, I completely agree with you. Thank you. And Tawfiq, do you have anything to share on this? I I think you are on mute, Tawfiq.
Oh yeah, now I'm okay. Can you hear me now?
Yes.
All right. I was just saying that yeah, the Raj so far will cover this, but I would just add small things. To balance between the cost and risk. Uh, Actually, we need to make some kind of calculated kind of a trade-off, or means that uh, we do the inspection according to the risk, which we call it risk-based inspection. Okay, so this is according to me is a good way that we can maintain reliable and safe operating plant, and in the same time with optimized costs. So from cost perspective, for example, we can do NDT but as targeted maintenance plan. Instead of inspecting every simple thing, every small thing, we come up with a plan. What exactly is degrading more faster? What exactly can bring more risk? And what exactly would be the consequence of this risk? Based on that, I can come up with a plan that, okay, so I have these components with high risk, so I'll focus here with more intensive kind of NDT and inspection and coverage, where less care can be given to the medium risk, and maybe for the low risk component, we can be deferred to another like time, for example, whenever like I mean we can have a plan for that. But I mean with lower frequency that does not consume our budget, and to focus this budget that we have for NDT and inspection for those items with a higher risk factor. So yeah, this is what I would say. Uh, so in short word, to spend the money where the risk is actually exists. Yeah, that's it.
Yeah, I agree. Yeah, there should be a balance. Like, um, so,
Yeah.
so for I mean, if you talk about like maybe down the road in maybe like 5 years, 3 years to 5 years ahead, how do you see the role of NDT evolving within predictive maintenance frameworks? For again, I'm trying to talk about like critical infrastructure because I feel like if it's critical, people really want to do predictive maintenance. I mean, so what do you guys think? Like in down
Okay.
the road in 3 to 5 years ahead,
I I would
do you
I
think
would say, I
AI would
mean,
be
yeah,
life
I
changing for
mean,
everything? It's
dig,
already
dig,
been
dig,
impacting everybody's life.
digitization is the thing that will be, I mean, everything will be, I mean, now everyone is asking for digital twins,
Yeah, yeah, yeah.
inspection results to be there on the cloud all the time,
Mm-hmm.
easily accessible to everyone. So digitization and definitely AI as well. Everyone is speaking AI. This is a trend in the couple last two
Yes.
years. So if you mention AI, so you are like moving with a trend. So, but it will come. It will come. To be honest, maybe it's not.
You think it would be in
Uh,
5 years down the road? Yeah, would be like completely engrossed in our NDT
it,
field, you think? Or maybe like 50-50?
it will take no, no. It will take some time still.
Okay.
But
Yeah.
you want to, because it's again it's machine learning. So the
Uh-huh.
more you input, the more reliable it becomes.
Yes. Yes, yes, yeah,
So
definitely. Yeah. You're right, perfect.
yeah, so it will take time, but it's definitely there. People are thinking about AI, how to use AI to deliver better values, better data, better
Hmm.
results, faster, because also
Yeah.
time is money. So
Yes.
whatever you can do in a day, AI can do in minutes.
Hmm.
So you just need to make sure that you are using the right tool, a reliable tool to deliver, I mean, accurate results. Also, what I can see also is that, which I have seen myself, that companies are tending into continuous monitoring wherever applicable. Like I can see people now doing this ultrasonic kind of continuous monitoring and condition monitoring, like humidity sensors and temperature sensors and all this kind of thing that give them indication about the most critical areas in the asset. So I can see it growing, frankly speaking, this kind of continuous monitoring approach, especially for the most critical assets. So I would expect also this to be grow more in the coming years as well.
Yeah. Yeah, right now the trend is like AI, but
Yeah.
still we are not there yet. I mean, things are evolving very, very fast. I can definitely, I can say that. But yeah, like you said, Tofik, it will take some time. And I don't think it's easily accessible either at the same time, like for some of the remote areas where you do like, but I'm definitely you can interpret it. But like you said, you need input. You need
Yeah.
database before you can um, analyze
Yeah,
that
exactly.
data. Yeah, based on the
Yeah.
prior experiences or
Yeah,
data.
a lot of data is needed because I mean to implement AI, it is different. It is different,
Hmm.
and there are a lot of factors to be considered. It doesn't mean that you have a data with crack indication that this file will help you to find each crack that may exist in any. No, the orientation of cracks, the length of the crack, the material actually you have, the joint configuration. A lot of things need to be considered before you think that, oh, you are ready now with the AI model that can detect any crack. No, it's not the case. You have to
Yeah.
have enough data to cover this crack in different
Mm-hmm.
conditions, different materials, and different joint configurations. Well, this should be considered before you can say, okay, my system is ready to be implemented and used effectively.
Yeah, I love that you pointed out different parameters of it. Yeah, it would take a while to get there, for sure. I can tell Dheeraj wants to say something.
Yes. So I think
Go ahead,
Tafik
please.
kind of like gave a very good overview, but I just try to top up some of the perspectives. So in
Yeah.
my view, I think, yeah, as he said, AI is not going to engulf NDT within the next 3 or 5 years for sure. It's going to be it's going to become an integral part, like maybe most of the things whatever we do, AI will be useful. It's kind of going to be a tool which we use to make our life easier, right? That's how I see it. It's not going to be a dominating factor, like screening the interpretation, helping in the data analysis. And I think just to touch upon, we talked about data, right? The importance of data, how good the data is. Do we have sufficient quantity of data, right? The
Yep.
quality and quantity of data is very important for predictive
Yes.
maintenance, right? So if you see historically, I've seen when I used to work with Exxon in operational plan, we used to have chunks and chunks of data, but to process it, human mind, it's going to be difficult. And sometimes we just like kind of make some judgments to pick up the right spots and do some assessments. But
Mm-hmm.
probably with machine learning and AI coming up, if you feed in all those proper data inside, you could get some fantastic trend lines and even better predictions coming out of it, right?
I think I agree on that, but maybe I can wait to ask what I want to ask. But how are we gonna analyze that data? What AI is analyzing? Who somebody should be there, like to, uh,
Yeah,
like,
right.
what's the authenticity of the data? I think we did mention that and talked about it earlier.
Right,
And
right. So
sometimes, yeah, go ahead. I'm sorry, Dheeraj. Yeah, you go
yeah,
ahead.
I know that's a great thing. I was going to come there, right? But as we say that we are going to we are going to do better, we are going to get more better analysis with AI or something in the future. We also need, like currently the setup is like technicians, we call it level 2 or something, and then we have SMEs at level 3 or something, right?
Yeah.
So the burden on the level 3s or the SMEs is going to increase because the more you use these kind of models, the senior technicians and the SMEs need to vet it through properly to ensure that the models are working fine. Because it's very common that you give good data, you'll get good results out. If you give bad data, then your results are going to be bad, right? So you still need the
No,
SMEs.
but I what I feel it. data is data. There's no data good or no data bad. That's what my personal experience, because I did like some research stuff and I did ask my professor like during my school. I was like, okay, this is good data. His professor was like, no data is good or bad. Every data gonna give you something. Why it's
Right.
not working? And I mean, it's okay to have a goal, but sometimes not having a goal can lead something really best. That's what my understanding is. That's what I'm really
Yeah.
had like, because I mean, it's just something what I had experienced. So
Yeah. But let me
I,
disagree with
my
you, Vinny,
my
this time. Sorry for that.
come on,
Uh,
man, topic. You cannot just
in
say that this time.
NDT, no, there is good and bad,
Yeah,
that.
there's nothing good or bad.
No,
My
in
two cents.
NDT
I
there
mean,
is. No, in NDT
yeah,
there is, honestly speaking,
yeah, yeah,
and I think the Raj
yeah,
speaking from like technical background, he knows very well that, yeah, there are data that cannot be interpreted because it's really bad data.
yeah.
Uh,
But Dheeraj, I'm sorry for interruption. I will let you finish your thoughts, and
Oh,
then we can jump on it and talk. I would love to
no,
talk about it.
that's a
Thank you.
great discussion, Vinny. Yeah, I mean, it really shows like how NDT world is sometimes slightly different from the other physics or the
yeah,
the kind of the
exactly.
scientific world, right? And it's a great discussion. So coming back to this, right? So to keep it simple, I feel like even though AI is going to increase in percentage of getting the integral part of NDT systems, right?
Yeah.
The SMEs or the specialists, the technicians will have to take more responsible roles of understanding the AI models or using them wisely and so on, right? So the burden on the final decision maker on, let's say, the service provider company, which can be a inspection engineer or a technician or whoever is it, right? So they will also need to vet through whether the models are working fine and you're getting the right output or not. So as you rightly said, it's not like it's just going to be independent tool. It's not like going to be a chat GPT. You put something, you check, it's going to be fine. No, you still need to vet through it and see if it's working fine. Because in NDT, as Traffic mentioned, the geometries differ. You're not going to inspect the same thing every day, right? You're going to inspect a different
Yes.
geometry, different
Yeah.
environment, right?
Yeah.
Different parameters. So it's very difficult to kind of nail down on one particular model which can work for everything, right? So that's my feeling. It's going to make our life better, but it's going to increase the responsibilities. We're going to get efficient and more productive, but yeah, it takes more efforts to get that happening.
Yeah, but I agree. Like AI definitely gonna help us. Like you pointed out, like it can analyze data quickly and give you something like summarized list of data or results. And yeah, yeah, I'm kind of, yeah, I'm with you on that for sure. Topic. Anybody, anything you want to add? So, what do you guys think about one NDT technique that would be like become most critical for predictive maintenance? Do you guys have anything in mind? Like right away, like as soon as like whatever comes in your mind, like okay, this could be the one. Nothing.
And it's again the same thing. What for what? For which damage mechanism?
Whatever
For,
you love
for,
doing it, that's it.
okay, if you tell me I need to inspect this flare tip, I will tell you, okay, drone inspection could be a good thing. If you tell me I need to inspect this, I mean, big sphere, I would tell you maybe acoustic emission, maybe automatic ultrasonics, this thing. But again, the thumb rule for me, the most dominant technique is ultrasonics. This is the most dominant
Yeah,
in
yeah,
the
yeah,
industry of NDT is ultrasonics. Okay.
yeah.
Uh, but to see the most critical, no, most critical mean for predictive. Yeah, okay, I would say it, since it is most critical for predictive maintenance in general, would be according to me ultrasonics. Still, as of today, is the main technique that we use to build all our assessments for
Yeah,
the structures. Yeah.
yeah. Ultrasonic. I'm 100% with you on that. And I think Gaurav Kaushik asked a question in our chat. He just want to know: can AI? I mean, AI could be used to scrutinize good and bad data.
I think so. I think so. I think yeah, because I
Why? Why
mean,
do you think that, Tawfiq? Why? What makes you think like it could be good? Because, like, I think you mentioned like AI. Again, AI running on the data. You have to have something before I can give you something. You need to give
yeah,
input.
right. Yeah,
So
because to say this data is bad, there is the reason, right? For the data to, for example, you got a noisy data, very noisy data. So I believe it won't be very
Mhm.
difficult for AI to detect that this data you have inserted is noisy data that may not be very accurate for further processing using AI. If you are using radiography, for example, I think AI can say that this image quality you are giving is not good enough for analyzing, or maybe the results won't be accurate enough. Okay, so
Mhm.
I think it can. In my opinion, AI can detect that this data is not good enough for further processing and analysis.
Do you think only level 3 should manage or analyze their data, or level 2 could be eligible for doing that?
Can be and can be not possible to be, because sometimes you have data that cannot be analyzed even by level 3.
Mm-hmm. Yeah, I agree. Do
Yeah,
you
because
think,
that itself is poor.
yeah, do you think other people like in management side or operational side, they should also engage in these kind of like analytical
Not
way to?
really. No, we are speaking now about NDT data.
That's what I
NDT
wanted to hear.
data,
Like,
this is absolutely technical thing that people who are qualified, certified, experienced
yeah,
can only do. Okay, yeah,
yeah,
not a management or anything. This is really technical thing. This training must be taken and experience. So we're speaking about very niche technical data. It's not just general data that you put in,
hmm,
or statistics that you put into the AI. No, it's absolutely technical data that really needs some specialist to run it
yeah.
through.
The Manish Ramamurthy sent us a message. He said NDT is important for predictive maintenance, but without proper RBI or any other tool, it will not be effective. NDT will be successful with proper implementation.
I think we said so already.
Yeah.
We mentioned that data quality is the
Yes.
first thing. After that,
Hmm.
integration of the data into a system that
Yeah.
can process this data, which should be RBI and so on. And it could be the other way around, by the way. We also mentioned that uh, to optimize the cost and risk kind of thing, we need to implement risk-based kind of inspection that can highlight where exactly is the high risk areas
Mm.
that need to be considered with more intensive NDT.
Yeah.
So yeah, what he said is absolutely
Yeah, to
correct.
add on to that, I think,
Yeah,
Do you want to add anything, Dheeraj,
yeah,
on it?
Diraj,
can you hear me?
please. Yeah, please.
Oh, yeah. I hope you can hear me now. Yeah. So
Yes.
yeah, to add on to that, what Manisha has told, I think, as we mentioned, right, the damage mechanisms and linking the right RBA and then implementing NDT is very important, because if, let's say, for one particular damage mechanism, you think ultrasonics is going to work, but instead, if you go for, let's say, radiography or eddy current or something, it's not going to be fruitful. So I think he highlighted it right. RBA
Hmm.
is a very keen integrator with maintenance planning as well as NDT. And
Yeah.
as I mentioned, I think we started off with that, right? Integrating a proper RBI is very important. And that comes with, kind of integration from materials, operational, and inspection background. So that's a very key. And I think I totally agree with them on that.
Yeah. And Suresh Mani wants to hear about like, please share about high order mode cluster guided waves.
Uh, okay, to start off, I can go first. So I've used
Yeah, please.
HOMC quite a bit. So for kind of corrosion under pipe supports, I think Tafik mentioned in one of his answers to previous discussions. So I think HOMC is quite useful in corrosion under pipe support applications. It's quite unique in the accuracy in terms of getting the right sizing of the corrosion bits, especially because it's invisible. Not a lot of techniques
Yeah.
can do it. And to complement it, within oceaneering, we have been using some robotic X-ray systems. Even we have been trying some CT systems,
Hmm.
like quite kind of exotic computer tomography systems and so on. But I think, as Tawfiq and I mentioned previously, ultrasonics is one of the core NDTs which is applied for kind of long range or this kind of cups applications. So HMC has been pretty much useful for corrosion to pipe supports in my perspective. Yeah.
Yeah. Thank you, Dheeraj. Thank you. I think we are running out of time. I would like to thank you all. Thank you, Dheeraj. Thank you, Taufik. Thank you, everybody here, like to our panelists for sharing such practical and experience-driven insights. And thank you to our audience. And thank you, everybody who ever asked question and your contribution in any way for your thoughtful questions. And I will now hand it back to our host for the closing remarks. Thank you, guys.
Thank you. Thank you, everyone. Thank you,
Thank
Mr.
you, Vineet.
Vineet and
Yeah.
Asim sir. Thank you to all our panelists, Mr. Mohammed and Mr. Dheeraj, for such a highly insightful discussion. We really enjoyed it. Today's session clearly highlighted that predictive maintenance is not just about analytics or software. It's about engineering insight, inspection intelligence, and informed decision making, with NDT playing the central role. So this recording of the session will be available on OnestopNDT's YouTube channel. So please feel free to revisit and share it with your teams. Thank you all for joining us today, and we look forward to welcoming you to the next edition of NDT Talks. Have a great day ahead. Thank you, everyone.
Yeah. Thank you all. Have a great day.
Thank you all. Okay.
Thank you.
Thank you.